This video is about recording the angle of a vector. We usually record the angle of a vector between 0 and 90 degrees, but we have a full 360 degrees that the vector can exist in, so we need a way of labeling where it is in that circle. So I'm going to show you a way that we do that. This vector is pointing perfectly east. I've just come up with this compass rose to help our direction. So I can see right now that the vector is moving north from east. I'm tilting it up so that it moves north from east until it's at an angle of 30 degrees. So the name that we would give that angle is specifically 30 degrees north of east. You had to start off at east and then go north by 30 degrees, or angle yourself north by 30 degrees to get to that angle. So I could label that angle 30 degrees north of east. If I had a vector that started north and went down 30 degrees toward the east like this angle would be 30 degrees east of north, if that makes sense. You started off at north and went 30 degrees east of north. So those two vectors are different. The angles are different from each other. So if we say 30 degrees north of east, that means something different than 30 degrees east of north. You can pause the video for a minute and see if you can describe these vectors using that same notation. I'll come back in just a second to give you the answers. Okay, here they are. You might have noticed that we can actually describe the angle of any vector in both ways, because we know that, for example, 75 degrees east of north, if you go 15 degrees further, you're going to hit the eastern mark. So that means it's also 15 degrees north of east. So if you want to flip the order of the words, you can actually just subtract your angle from 90, and the result will be the other angle when you have the words flipped. So 28 degrees north of west, if we subtract 28 from 90, we get 62. So 28 degrees north of west is equal to 62 degrees west of north. It's a convention in physics to almost always draw the angle of a vector between the vector and an imagined horizontal line. In other words, we usually record vector angles in these directions: north of east, north of west, south of east, south of west, and we rarely use other directions. So what I'm saying is that we imagine that there's a horizontal line at the base of the vector like this, and the angle is recorded between that horizontal line and the base of the vector. We very rarely use vertical lines. We will sometimes, but it's more rare. The convention, just to make it a little easier, is to always use the horizontal. So vector angles will normally be recorded like you see on the left rather than on the right, but the right is still definitely fair game. We can still record angles that way, so we'll have to show you how to deal with that later.